the same for 5 and 8. And as you can guess, for 1 and 1, there's no way to do it. All right. But then now we try 2 and 1. All right. Well, with 2 and 1, we're going to start the same place. Try an index of 1. With this, if we take the 2 minus the 1, there's no solution. We can't use that. All right. But we can now going from 1, 2 to 0, 2. All right, with that, we're going in the wrong direction because we have an index 1 taking us to an index of 2. All right, so that fails. Next try, going from using the second element. All right, so with this, if we use the 2, we can take and go over 2 minus 2 columns, and with this, that has a 1. All right, and 1 is less than 2, so that's a suitable solution. That is, to solve for together, a 1 and a 2. All right, with this, from this position, this says use the element with index 2. All right, fine. We see it's a 2. So with this, we could try and do 2 different things. We could try to do 1 minus 2, all right, which is going to take us back to rows. Well, that's outside the table, so that's not how we did it. The other way we can go is to take the second value and subtract that from the column. So 2 minus 2 is 0, and there we have an index of 1.
So that works.
So with this, right, so we've covered the 2 by using the 2. Now we're down to 1 and 0. And to solve for 1 and 0, using index 1, we can take and subtract 1 from the row to get to 0, 0, and that's the end of the road.
I kind of understand what you're saying, but I think I still need to do a lot of thinking.
Well, I mean, with it, the thing is seeing how little there is to the pattern. All right, because it's the same pattern, but there's 2 ways you can go with it. You can go go backwards in the columns, or you can go backwards in the rows. And how far you go depends on what value of S you're using. All right, now for 1 and 3. All right, for 1 and 3, the notion is, again, well, we could try using index 1.
1. Okay.
All right, that has a value of 1. And with this, if I subtract 1 from the row, that's a problem. We're going from a 1 to a 2.
Okay.
All right, and so we try the other way, and we go from 3 to 2. And again, it's going the wrong way because we would have a 1 taking us to a 2. So then we try the 2. Well, with the 2, if we try to go backwards 2 in the rows, we're outside the table. That's a problem.
Okay.
And then we could try going 2, and that takes us to a -1.
So
that's a problem. All right, so that takes us to the 3. And with the 3, the notion is if we go back 3 in the rows, we're out of the table. And if we go back 3 in the columns, that takes us to a 1, and that's okay.
Okay. Yeah, I think I kind of get it now.
All right.
Okay.
But the idea is, whenever you write down a value, it means if you take the row and the column, there is a solution using only those elements. All right, so when we write this 3 down, it means I can get a sum to 1 and a sum to 3 just using values among these 3.
Up to that point.
Up to that point.
Right,
of course, we want to minimize the value that we write.
Sure.
All right, because if we don't minimize it, we might run out of elements
But since
later.
we're going from left to right, it's always minimized, right?
Right, exactly. Right. So with this, if it's not minimized, and there's something being rejected incorrectly.
Right. Okay. I think I kind of get it. Did you?
It's just reusing the same idea as the one-dimensional version. All right, then like here to solve for 4 and 1. All right, with solving for 4 and 1, can't do it.
So these are the index values.
Yeah, because if we try solving 4 and 1, the problem will be we try to use the 1 and go this way. It's the wrong direction, right?
Why is the wrong direction?
Then going this way, going from a 1.
You can't go from a 1 to a 3. You can go from a 3 back to a 1. Yes.
The idea is eventually when you do the final back trace, which is just undoing what we've done, you're going to do a combination of going back columns and going back rows. And as you do that with this sequence that we have, these values in the cells have to be in descending order. Because if you ever go in ascending order, you can easily get duplicates. You know, if I give you duplicate values, it's a different problem.
Okay, I think you kind of get it. I'll do some more thinking.
Oh, I'm going to repeat this a lot.
You guys have any questions?
Can you do keep doing for finish this
Okay,
row?
well, with this, the next one, for getting 4 and 1, we try index 1. So with this, going from a 1 to a 3 in either direction doesn't work. So then we try the 2.
Nope.
Either we go outside the table or we go to another 2. Then we can try the 3, which either takes us out of the table or to a case it doesn't have a solution. Then next the 5, that takes us too far each direction. Same with the 8.
There's no solution there. -1.
Right. And then next with the 5 and the 1, this is a good one because with this we tried the 1 going this way, it's a 3.
Nope.
Can't this way, doesn't have a solution. Then we try the 2 and this way, going from a 2 to a 3.
That works.
No. I put a 2 here? You can't
Well,
go.
no,
The order's wrong. The order's wrong. If I put
you can't go to... Yeah, that's
all
right.
right, so you can't do that. All right, and you can't do 2 in this direction. So then we finally get to 3, and with 3 I can go 1, 2, 3. That's a 2, so that's a winner.
But as long as this one works, this one doesn't matter?
Right.
Because if you go this way, you're clearly out of the table.
Right.
Okay. As long as one of
Right.
the
So
two
with
works.
this, with them, so you can certainly, and you will have cases. For example,
If one of the two way works, then it works.
well, for example, if you're solving for a CII, in all cases you can go either direction. All right, because they're the same value.
Yeah.
All right, but the idea is each time you stop to fill in with the index going through the indices, you can't do something like check all of these in this direction and then check all of these in the other direction, because it has to be the smallest possible value trying in both directions.
So which one? This one is 4, right?
Let's see, for 6 and 1, that's going to
5 and 3.
1, 2, 3, 4. Yeah, that works.
Let's see, 6 and 1. For 6 and 1, we have a problem. Because if I try to go
1 doesn't work.
1 doesn't
One
work.
doesn't
Then if
Two
I
doesn't
try
work.
2, that doesn't work.
3
3 doesn't work.
3 doesn't work either.
And then
5.
5.
4. So that one index 4, right? So we
Index 4 has a value of 5.
Value of 5.
Oh, we put a value, not the index.
Right,
Okay.
right. So we have to, so when
So
we're going
5?
backwards,
Okay.
you're using the S value itself.
Okay.
So this case, going 6 minus 5 doesn't have a solution.
Oh, 6 and 1.
All right, so this one, no way to do it.
No way. Okay.
Yeah.
Everybody get it?
Kinda.
Aren't you glad we have machines to do this?
Well, we just need to understand the logic behind it.
Yeah. Oh, it's, well,
Yeah.
it's
So
completely about understanding the one-dimensional version.
Okay.
All
Does
right.
you mean this one is sub problem, right? Is
So we do the same thing on every row.
Right. So every row you're doing the same thing.
So how do the back trace?
Well, the idea is that the back trace is first of all,
You have to fill in.
got to make sure that this is something besides a -1. Because if it's a -1,
Exactly.
there's no
No
solution.
Clear.
Otherwise, you take whatever index, I'll call it K.
Okay.
All right. And with this, you could save an indicator that says whether you came across the columns or you came across the
So
rows.
go K this way or that way.
Right. All right. So you could do it that way, or you could just redo the cost function. Because here, if I take whatever K is, that value, I can then take and subtract it from the column I'm in, and if it takes me someplace legal, it's not a
That's one way to do it.
-1, and
That's one way to do it,
And right. And if that doesn't work, well then, you better be able to go back in the row.
Right.
One of the two has to work. All right, so that's it. So whichever one works, you go backwards and you continue from there.
Yeah. You get it? I mean, I kind of understand the logic. We just have to figure out a way to write it.
It's really just like the one-dimensional version, except you have to figure out, did I come from the left or did I come from above?
But these values are index values.
Yeah.
And then when you take it to the table, then you know the real value. So you can do it either way. Like he said, you can go K back this way, or you can go K, subtract the value at that point and see if it matches the math that we did. So I kind of get it.
Yeah, and with it, it's. With it, dynamic programming is really